welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice. I'm a host at House of ZK. I'm joined here today with Michael, who is co-founder of Brevis for the Brevis Special. We'll be talking all about Brevis's latest developments in real-time proving and also use cases across their main offerings with their zkVM and their coprocessor. So thank you so much for being here today, Michael. Really excited to have you again.
Thank you, Alice, for inviting me here again, and super excited to talk about what we have been building lately.
Yeah, sounds great. And before we go into some of the details of what you guys are building right now, I wanted to go back and ask you about the origin story behind Brevis. Very curious to hear about where it all came about and why you wanted to focus specifically on the idea of verifiable compute.
Yeah, this is a great question, right? So on the market, there are a bunch of ZK projects, and many of them are infrastructure focused and verifiable compute. So we, in fact, we didn't want to really build a verifiable compute product or project per se. So the entire Brevis project came from demand from a real world user and customer demand. That we see in the entire DeFi world, right? So the original motivating example was actually super simple. Is that we have a bunch of DAX partners, and they are interested in kind of making their DAX user experience more sophisticated than just treating everyone the same. And one kind of a simple way to do that is to at least give some trading fee discount for some loyal users or some whale traders who traded a lot in the last, let's say, 30 days. In the next 30 days, they get a VIP tier and get some fee discount. So, what they quickly realized that, is that, okay, so they actually kind of build the next generation of their DAX system as more of a modular system that you can actually have a possibility to adjust the fee for individual users customized way. But how do you do that, right? So there's actually no way you can compute what is users trading volume on chain in the last 30 days without actually bankrupt this user in gas fee. So this was a very kind of a motivating example, because even after so many years of layer 2 scaling or blockchain scalability study, we still are at a point that the scalability of blockchain even on layer 2 has not reached the point that you can actually do some very heavy and data complex computation easily. So this is why we felt that this is a good time to actually find a solution for that. And now we do this in a first principle approach, right? So we ask ourselves, what is the fundamental reason that blockchain application or smart contracts themselves are slow? Of course, there's kind of the VM construct issues, but the more fundamental reason is that the entire blockchain right now is built in this re-execution based model. Every validator, execute and compute the same thing again and again across the entire network to achieve consensus. Layer 2 is better, but essentially it's still the same, because you need to kind of settle on layer 1, and that settlement process is also kind of incurring a repeated computation across the whole network as well, right? So this kind of replicated compute based consensus is something that we feel that should be changed. And this is where we discovered the verifiable compute, especially using ZK, is that you can actually just have one node or one party that is doing the actual computation and at the same time generate a proof, so that everyone else can just verify the computation is done correctly. And in that through this kind of a new pattern, you can essentially offload this kind of very complex and data-heavy computation away from blockchain to an off-chain entity and generate a ZK proof, and let the blockchain and all the essentially all the validator nodes in the blockchain verify the proof with extremely low cost. So nice thing about ZK is that no matter how complex the original computation is, you can always verify it in almost constant time and cost, and very tiny amount of cost, of course. So this is reason we want to enter this space, because we do see not only just DAX is just one example. We heard a lot like in terms of reward distribution, how to build new generation of perpetual swap, and so on and so forth. They all want this kind of a computation power that is just simply not available anywhere in layer 1, layer 2 blockchains today. That's why we built Brevis.
Yeah, thank you. And it's great to hear about some of the different examples or the use cases that you mentioned, like you've mentioned, for example, with the DEXs and seeing it as a more modular system. But when faced with the question, well, what is the user's trading volume, for example, for the past month, it's really hard to get that kind of data on-chain and to just be able to find that out without, as you mentioned, like bankrupting the user in gas costs, because it is quite expensive. And you do mention a good point that even though there's been a lot of work behind scalabilities for blockchains, especially with the layer 2s, we still cannot do the heavy sorts of computation on chain easily. And you also mentioned with the say like smart contract-based applications, why they're so slow. One reason is because we have the re-execution-based model across these validators, but ZK offers a solution where we only need to have just one party be able to generate a proof, and then anyone is able to validate that proof from there. So it's a lot more scalable and it's a lot more succinct in that regard. So that's all great to hear. And I wanted to also ask you more about some of Brevis's latest developments with Pico Prism. So curious to hear about like why Brevis chose to build its own distributed proving system and what this means for real-time proving.
Yeah, for sure. So I think kind of to explain Pico Prism, I kind of need to explain what is Pico, right? So like we have this kind of a magic box that can do verifiable computing off chain and generate zk proof. So what is actually inside the box? The center of this whole kind of computation, infrastructure is something called a Pico zkVM. So what is a zkVM? Well, zkVM is this kind of a virtual machine that you can essentially use for general purpose computation, and you can essentially turn any kind of software computation or software execution into verifiable compute. Like no matter what kind of software you wrote, right now we have a complete Rust toolchain. That is like if you write and you're programming Rust, you can easily generate a zk proof of the program's execution, right? So what that means is you can essentially turn any kind of software you want, into something that a blockchain or any other party can easily verify the computation result is generated correctly. So the reason this is very useful, especially for like a layer 1 blockchain like Ethereum, is that we now can essentially use this general purpose zkVM to execute or to run the Ethereum full client, which is like in this case RIS, right? So Rust client of Ethereum. So what it means is that just like I said, you can now have one single node in the entire network that is just doing the actual computation and also generating a proof of the block execution, and then let everyone else in the network just verify the proof itself. So there are really kind of two ways to use Brevis. One is that you kind of treat the blockchain as a single entity, and then you offload the computation to Brevis and wait the result to come back with a zk proof into the smart contract. But another way, when you're actually kind of modifying and changing the underlying construct of the layer 1 blockchain, is to replace some of the blockchain's core construct. That is how the consensus is actually achieved, right? So this is like how we can do this. Now the reason this is important is because once you have this kind of capability, once you can do this fast enough, you immediately reduce the cost of Ethereum block execution and essentially gas fee. What it means at the same time is that you can increase the block size. Essentially, you can pack a lot more transactions in a single block. You can generate the zk proof if you can do it fast enough. Everyone else still just need to verify the very simple and succinct proof across network, right? So like no matter how much transaction you theoretically stuff into the single block. So if we can catch up, like in terms of proof generation process, catch up with the block producing time, what it means is that you can start to actually kind of add more and more transactions into Ethereum layer 1 blockchain to scale it even to the level of like what people see in Solana and other kind of high speed blockchains. So that's why it is important, and that's why generating a real time proof for current Ethereum block will be a first step and very important step towards that 100th time scaling future. So before Pico, no other zkVM can achieve like 99% Ethereum block real-time proving for 45 million gas blocks, no matter on what kind of a machine they offer. But what we do here is that we can essentially generate like a proof for 99.6% of Ethereum blocks with average proving time of 6.9 seconds on just consumer hardware. Like 64 GPUs is something that we need, right? So this is like really a breakthrough for us because we feel that this is really opening doors to achieve a new level of scalability and also at the same time decentralization for the entire Ethereum ecosystem. And this is like precisely why after we launched the Pico, we launched this new version, which is a multi-GPU parallelization version of Pico that can allow you to kind of achieve this level of performance. But in addition to the amazing performance that we can achieve with this current set, the important thing about Pico Prism is the architecture itself. So we now have the capability to essentially run Ethereum block execution close to full kind of a linear parallelization. What this means is that we essentially turned, this is the first time in history we turned Ethereum scalability problem into a pure money problem. As long as you can throw more and more and more GPU into this, you can do enough parallelization to essentially stuff more and more transactions in a single 12-second block, and you can essentially linearly increase improvement in Ethereum kind of a transaction capability once you have this kind of a verification client enabled. And this is something that we're just a kind of quick teaser. This is something that we're gonna also have some update on, like the new kind of new generation of Ethereum full client in the upcoming Dev Connect. So I think we're hosting this event together, and people should definitely join to take a look at the demo for sure.
Yeah, absolutely. And those numbers seem really exciting as well, especially with the linear parallelization. So basically, as long as you have enough GPU compute, you can see almost linear improvement in the performance there. And it's also very exciting to see that we've gone so far from ZK just a couple of years ago. We were only able to prove certain things, and proving the costs were just a lot more expensive, and it just took so much longer to do. But now we had the use case where we can prove these Ethereum mainnet blocks in real time, which is very exciting. And as you mentioned, this is just the first step of kind of this scalability end game that we're trying to go for. So we have a lot more to come. And on this topic for real-time proving, I'm curious to hear once we reach full real-time proving on Ethereum, what new applications do you see that can be enabled that weren't previously possible, and anything specific that Brevis will be building towards?
Yeah, so I think real-time proving, as I mentioned, the most kind of direct impact is blockchain, the underlying layer 1 blockchain scalability itself. Now once you have higher scalability in Ethereum layer 1 blockchain, you can do a lot more things, generally speaking, right? So you can add a lot more intelligence into DeFi applications and so on and so forth. So that's a given, that's for sure. And but what I want to highlight here is that kind of a proving Ethereum block execution in real time is more like in another way, it is also a benchmark, a very good benchmark for where the performance or how far the performance of zkVMs, especially like Pico, has gone, right? So so what this means is that now we can even prove Ethereum block execution in real time. You can do a lot more things, not just Ethereum computation, but for example, we have seen this trend in our partner expansion as well, right? We started with Uniswap, PancakeSwap, Euler, Linea, MetaMask USD, and all these kind of blue chip DeFi partners. Their use cases are mostly kind of half on-chain and half off-chain, right? So like you have a bunch of application logic that is on chain, and then you migrate a bunch of like heavy computation to the off chain world, and then the computation comes back like either in the form of like loyalty program, reward distribution, chain growth, stable token growth, and MetaMask card reward, and whatever application that people build, but it's kind of a split half and half. So as we start to see the level of computation, the level of kind of performance increases, for on Pico Prism, we start to see more and more kind of application moving more and more logic to the off-chain world. And I think this is like a very important trend. That is, in the future, in I think 5 to 10 years, like I think 99% of the entire blockchain application computation is going to happen off-chain and happen in a verifiable way, right? So one example I want to mention is that we're working with a very major perpetual swap exchange partner that they are actually kind of migrating their entire matching engine logic off-chain, but using ZK to essentially generate proofs in real time for the matching engine kind of match result, and then settle that on chain, so that even though that you get the same kind of a user experience as if you're using a centralized exchange, but you get the same level of security and transparency like you're using a DEX essentially. And at the same time, we have to also note that there's also kind of inherent benefit from kind of a zero knowledge part of the zero knowledge proof, right? So like we have zero knowledge proof mostly as used as a scalability solution, but the privacy property is also there, right? So you can essentially hide a bunch of orders you want to review. You can do dark pool orders that was not previously available in DEXs. So these are all the kind of trends that we're seeing, that performance is actually gonna as the performance increases, the kind of scope of feasible use cases that can be run in verifiable computing also start to increase.
Yeah, got it. And it's really exciting to hear that the Brevis team is not only looking at the scalability aspect of ZK, but also the privacy one. And you mentioned that, say, within DeFi, there's not just those applications that are relating to scaling, but also some like relating to, for example, you mentioned the dark pool orders or keeping certain transactions private. So yeah, really exciting that we can finally utilize both properties that ZK is really known for, both in the privacy aspect and also the scalability aspect. And just also curious about any potential drawbacks or current limitations when it comes to real-time proving, especially with the performance of not so ideal blocks, like worst case blocks. I know some projects and some other organizations are having these prover killer transaction initiatives. So those that are like really heavy in their precompile operations, or just like single transactions that just have like an excessive amount of gas. I wanted to hear about like any kinds of limitations that we currently see within real-time proving, especially as we consider things like for these not so ideal blocks that we might need to prove, and how we can go about with addressing these current challenges.
Absolutely. So like, I think there are two kind of answers to two layers of the in my answer to that. Like, the first is that I think there is a kind of recent EIP that I forgot the number, but the idea here is that we should limit the maximal gas for a single transaction. That really kind of solves a lot of problems, because like I think the limit was like 15 million or something. I forgot the exact number, but like, once you have the upper bound of the transaction, what it means is that the lower bound of the latency you can go is to kind of prove that single transaction, like the worst case single transaction, right? So now like what about like kind of prover killers? Let's say in 99% of the cases your hardware setup is like sufficient to actually prove all the kind of blocks in real time, but for that 1% of cases you kind of need to really add more GPUs and stuff, but you may not have time to add that. Well, so this is the idea come from Justin and kind of the Ethereum Foundation team. That is like you can essentially use mechanism design to solve this problem. That is you should incentivize, because zkVM is going to be enshrined in Ethereum layer 1 in the future. So you can essentially do this design where the validators themselves are the ones that are responsible to find, the block producers themselves are essentially the ones that need to kind of generate the ZK proof as well. So like when the block producer is producing blocks, they will be cautious to not kind of put too many kind of transactions that can cause kind of a proof killer. Because if they do that, what it means is that their reward get like reduced or their kind of stake gets slashed, right? So that's a very elegant way to solve this. That is, as long as we have like most of the common and normal blocks covered, then for the rest of the 1%, we're just like using mechanism design to solve that. But you did point out a very, very important aspect of this is that in any kind of a system design, there's always this trade-off between the generality and the performance, right? So zkVM is very, very general. You can really run any kind of software, any kind of computation on top of it. But at the same time, it means that for some use cases, it will sacrifice performance. It is not going to be as fast as your specialized circuits. So what do we do here? What the solution to this is that we build Pico as a very, very modular zkVM, where you can plug in something called application level coprocessors. So what are these application coprocessors? Are essentially these application coprocessors are essentially specialized circuits that handles very commonly seen use cases. So we have something called zk data coprocessor that is helping you to prove existence and completeness of historical on-chain data, such as users' trades, users' position, users' token holding in the past. So this kind of coprocessor really helps you to improve the performance and reduce cost when you're dealing with this kind of use cases, right? So this is something that is very unique in Brevis. That is, we have this kind of a computation, very powerful computation core, which is the zkVM, but we also have a way to plug in a bunch of different coprocessors to extend the functionality and improve performance in many of the commonly seen use cases. And this is how we can build a full stack ZK compute stack.
Yeah, that's great to hear that you're balancing both the generalizability component and also performance component. So in this way, in order for Pico to be modular, there's a way where you can plug in, you mentioned these application level coprocessors, which function as these specialized circuits to extend the generalized functionality of the Pico zkVM itself. Got it. And it's also good to hear that right now the Ethereum community is also thinking about, say, for example, these worst case scenario blocks. And you mentioned that EIP proposal, as well as even just like a change in incentive. So having those block producers themselves also be responsible for generating the proof and then being more cautious as to like which transactions to put in a given block. So yeah, good to hear that all of these, kind of either trade-offs or just like worst case scenario cases are being considered here. And you also mentioned that like in the future, we may see the enshrining of a zkVM within the L1 of Ethereum. So I'm curious to hear in that regard, would we reach that case, say if Ethereum were to enshrine its own zkVM, are there any types of ideal design considerations that you anticipate that zkVM having? Like, for example, a specific instruction set architecture. A lot of zkVMs on the market today are using like a RISC-V based ISA, and if there's any other kinds of design considerations that you see as really ideal that have also informed Brevis's current design.
Yeah, I think there are a bunch of so this is like Justin had this kind of site that is a layer 2 bit equivalent in zkVM called easeproofs.org. Yeah, and what that is essentially kind of a way to track the performances and the various aspects of the different zkVMs against an ideal or acceptable case for enshrining into Ethereum layer 1. So there are several aspects of this. Of course, obviously, the bottom line is the kind of performance, right? So you have to kind of have a real-time proving capability and also cost. So the ideal scenario here proposed by EF is that you need to kind of have the cap X of about 100K and a power draw of around like 10 kilowatt. And what that is basically a 16 GPU cluster. 16 5090 is basically that kind of cap X and also power draw. What it means is that now you can really just like run a home compute node to essentially prove Ethereum blocks in real time, right? So where we are now is that we are still about 2 times. We're already there in terms of performance. The version that we released, the first version of Pico Prism, is still 2 times, a little bit more than 2 times, larger in than the ideal costs. But we're rapidly kind of progressing towards that. So like I think in just like a couple of weeks. When we get to the DevNet, we'll kind of release a new version that will probably reach this kind of a performance requirement. And then after that, it is the security, like in terms of both audit and formal verification, but also the security of the VM itself, whether it's post-quantum secure or not, whether it has enough security in terms of like the bits level and proof sizes, and proof verification costs, and these are all the considerations. But I would say those are like relatively easy to achieve because we clearly know how to get a formal verification of zkVM. We also clearly know how to get audits, right? So, but the performance and cost aspect is something that is something that is kind of an unknown, and every team is kind of racing towards that for sure.
Got it. So there's kind of like 2 main priorities that these zkVMs, and especially those that are involved in the ETH Proofs initiative, are looking at. So one is with those performance considerations, being able to generate a certain number of proofs for these blocks in a certain amount of time, and then also the security considerations as well, like even on the level of the zkVM itself with the formal verification. So there's 2 kind of main priorities there. Got it. And I also wanted to speak a bit more about the Pico zkVM itself. You mentioned that it was made to be modular, and I know that Brevis has kind of like modeled this based on the glue-and-coprocessor architecture. So wanted to hear about what this idea for a glue-and-coprocessor really entails, how that contributes to Brevis's current general purpose zkVM with Pico. That can be integrated with these specialized circuits, that can be integrated with these application level coprocessors, as you spoke about previously. But yeah, I just wanted to hear some more details about the intention behind using the glue-and-coprocessor architecture, how that contributes to modularity, and if there's also any kinds of scenarios other than zkVMs that you can see it being applied to.
Yeah, absolutely. So, first of all, glue and coprocessor is not something that is, we invented. And, I know Vitalik also kind of wrote this in his blog, but it's not also not a concept that is invented by Vitalik as well. So the glue and coprocessor architecture is something that is very commonly used in, modern kind of computer system designs, right? So like in the entire Google services are running on glue and coprocessor architecture. You have like something called a GFE, and then the GFE handles everything as a glue, and then calls into this kind of specialized services like machine learning, like search and everything, to can then stitch all the result back into a single thing to represent to the user, right? So it's a very, very common kind of design that can be seen everywhere. And it's not surprised that we see this in blockchain as well. Vitalik also mentioned, in his glue and coprocessor architecture argument, that is in the future, blockchain itself is going to be acting as more of a glue, the layer 1 blockchain, and then you have a bunch of coprocessors such as such as layer 2, and ZK systems that can essentially act as a coprocessor for the blockchain itself, and then kind of just deal with the special purpose result, and then kind of return result periodically or asynchronously. So now in terms of like Pico's zkVM design, we also designed it this way. That is like we have a very general purpose zkVM with like very general RISC-V instruction set that can run any kind of a computation you want. And then for specialized computation or specialized operations, we want to accelerate further. Then we kind of plug in some specialized circuit or specialized systems in. So for other zkVMs, what we have seen is that there are also coprocessors in those VMs, but they are kind of a low level in the form of precompiles. Their purpose is to accelerate certain small bits of computation, like hash computation, like cryptographic signature verification, ecliptic curve operations and stuff like that. So, but they're not really focusing or aware of the application need on top, right? So what we can do in Brevis's Pico architecture is that we have all these kind of slots that is available and easy to plug in for application level, co-processing capabilities. Let's say you want to do like AI-based verifiable AI, thing, or you want to kind of bring Web2 data to Web3 by generating a zk proof of your TLS session, or generate a zk proof of your large language model output. So these kind of things can and should be specialized. It should not be run in a general purpose zkVM. And we have all these kind of a very complete recursive verification framework that you can bring all these things in. And in-house we built the zk data coprocessor, which is the reason why you see our go-to-market and partners contains a lot of these kind of mass adoption user-facing applications, because many of the user-facing applications need to have this capability to generate kind of a historical data proofs, historical user event proofs, to understand user profile, to understand market condition, to dynamically change and customize user experiences or change entire protocol settings. So yeah, so that's that's why we have this architecture.
Got it. And in making the zkVM modular itself, like in addition to being able to integrate these coprocessors or specific circuits, are there any other types of like features which makes the Pico zkVM modular, for example, being able to interchange with the proving backends or have any kinds of customizable workflows in relating to proving? Just wanted to hear more about like what differentiates a modular zkVM versus one that is that stays to be generalizable.
Yeah, so like totally. So what I mentioned, the modularity is kind of the kind of modularity that matters. Is most kind of exposed to the end users and developers, because like they know, okay, you can use kind of different coprocessor in Pico, but Pico itself is also highly modular in the sense that you can actually change the proving pipeline, you can change the proving backend easily, so that you can essentially build your own VM like Lego pieces. So if you don't really care about on-chain verification, you can ditch the entire kind of aggregation compressed process. You can just like use Stark proof directly, and that saves you some time. And however, for some of the workload that intensively use hash operations, you can even change the proving backend altogether to accelerate for that. So like all of these kind of pieces are built in a very modular fashion, and the important thing about this is that you can, of course, like build your own VM, but also make the Pico extremely future-proof, because like what we have seen is that zk is the entire zk space is evolving on multiple levels, right? So from the engineering, from the framework, and also like very importantly for the underlying cryptographic research as well. Right, so like we may have like new curves available, we may have new kind of a proving system available, and no matter what that is, like you can actually easily plug into Pico as well, right? So because for example, we started with the baby bear field, but now we changed it into the koala bear field for proving, and that will just like really kind of require one line of configuration file change. So that's that's kind of like the power that we have, like as kind of a more of an evolvable and future-proof system.
Got it. So there's a lot of flexibility even on the end user's side. Like for example, if they wanted to change the proving backend they use, like you mentioned, for example, some users, they may not need to do any kind of on-chain proving, so they can just stick to the Stark backend. And then there's different parts of that proving pipeline that one can kind of tailor based on the use case or the application that they're building.
Yep.
Got it. Mm-hmm. And it's also pretty great to hear that, like you mentioned, for Brevis changing the type of field that you're using, that's only really needed like for a one line code change as opposed to like a complete rewrite. Yeah, definitely really agree with your point that right now we're at this stage where a lot of new developments are being made. We'll have potentially in the future new proving backends being introduced, or maybe even new fields, other kinds of these components that need to be incorporated. And we need some sort of system structure that allows for these new additions or these new edits to be made without having to rewrite the entire system. So it's great to hear that Brevis has that in mind. And then also just more on the idea for these application level coprocessors. You mentioned that a lot of the zkVMs that currently exist, their approach is more to do with those individual low-level, function-level precompiles. But wanted to hear some more about some of the types of application-level coprocessors that Pico can be integrated with. You mentioned that right now there's the in-house zk data coprocessor that Brevis has. There are some you also mentioned some AI-related use cases as well. So wanted to hear if there's any kinds of zkML-related coprocessors that can be integrated, or any other kinds of on-chain data coprocessors that are able to be integrated with applications that can generate these historical data proofs. So wanted to hear just some more details about those different types of application level coprocessors that Brevis can offer, and any types of new applications that Brevis can enable with this integration. I know that, for example, right now Brevis is working on Incentra, so the verifiable incentive distribution application. So wanted to hear some more details about that as well.
Sure. So for the application level coprocessor, right? So there are a bunch of things there. So we obviously what we already have is something called a zk data coprocessor that focus on essentially allows your smart contract to access and compute on any kind of historical on-chain data, such as events, states, and transactions, right? So this is where a lot of our intelligent DeFi use cases were really born, because for intelligent DeFi, the intelligence really comes from on-chain interactions for users and also the markets, right? So for example, we power dynamic fee based on market volatility, based on token holding, based on user trading volume, on PancakeSwap, Uniswap, and all these different quick swap, Sina, and many other kind of major DEXs is rely on this feature. Already have this kind of live in production, and it is really amazing that it's once you have this kind of feature, you start to have loyal traders that are trading more and more on these pools, and because they're essentially getting very low fees, they're market makers essentially. If you think about it, for centralized exchanges, they also have market maker rebates program, right? So this is kind of similar, that helps you to build a better structure for your DEX, and therefore your DEX pairs and pools are quoting better than other DEXs, and therefore the aggregators will have more flow, user flow, or order flow guided towards your pool. And in the end, even though you're seemingly lowering fees for some loyal users or loyal traders, but in aggregate, your actual fee and actual revenue percentage increases because you get more order flow, especially kind of uninformed order flow from retails. So that's that's kind of like the powerful thing about this. And then for reward distribution, right? So like today's if you launch a chain, first thing you need to do is to kind of help grow the chain's DeFi ecosystem, right? So but how to do that? You want to kind of incentivize across the ecosystem with your native token, right? So but there's no good way to do that now until because like you either do it in a centralized way or you don't do it at all. But doing it in a centralized way create a lot of compliance, security, and transparency issue, because users are just first of all, you're just distributing randomly to some random non-KYC user constantly through a single entity, and then you're risking the lose of the distribution key. And then finally, users are not really understanding why some other users getting more tokens than they do, right? So there's no way they can verify it easily as well. So what we do is that we build this kind of zk power system where users themselves can generate a zk proof of their interaction and contribution into the blockchain ecosystem, and then use that as a way to claim the reward. And this is this is like an example of this is that we recently launched with Linea, something called Linea Ignition program that is distributing 1 billion Linea tokens in 10 weeks by allowing users to kind of deposit liquidity, do trades, do yield aggregation across the entire Linea ecosystem, and generate zk proof for that, and use that zk proof as a way to claim and receive reward from this program, right? So this is a transparent, secure, and also compliant. So also similarly for real-world assets like stable tokens, we can also help them grow by essentially running this continuous protocol incentivization to help them better embed into the DeFi ecosystem in lending protocols, and then in stable swaps, and in many other kind of DeFi ecosystem. So that's also kind of a pretty major thing we're doing, especially related to coprocessors. But other than, there are so many other kind of examples. I probably we probably don't need to go into all the details, but this is definitely our flagship thing. This is why we have a lot of the very unique partners we're very fortunate to work with. But we also have something called the zkTLS coprocessor. This is something that we integrate with some of our partners, like Brevis and others. So it really allows you to essentially generate proof of your off-chain data, or kind of Web2 data. For example, if you want to kind of get a trading fee discount by proving that you're actually a big trader in some centralized exchanges, now you can do that too by generating a TLS proof of your historical trading volume, let's say on Binance or on Coinbase or anywhere, without actually revealing your detailed transaction history. You can just say that, okay, I generated a zkTLS proof, proving that I now get a bunch of data, and then I kind of add all this data together as my kind of trading volume in the last month. I can prove to you the computation process of adding all this number up is correct, but also the raw data is actually coming from Coinbase.com, not something that I fabricated, right? So that's just another example of that. And also we're working with a bunch of zkML projects to kind of build zkML coprocessors that allows you to essentially generate proof of a certain machine learning algorithm output. This is going to be broadly valuable for a medical kind of AI use cases, especially decentralized AI use cases and AI agents as well. So if I'm an AI agent and I'm paying the other AI agent to do something, I want to make sure that the other AI agent I'm paying is actually carrying out the work, and not just kind of get switched to a lower performance model or something like that. So these things are all possible via this kind of a coprocessor model as well.
It's great to hear all of the different types of applications, the extensibility of these different applications that these coprocessors can allow for. and while balancing the general purpose aspect of the underlying zkVM that it's integrated with, but at the same time be able to specialize in these certain use cases in these special operations. And then you even mentioned before, like with these other zkVMs that focus more on the precompile side, it's a bit limited because there's only certain like small, say, cryptographic operations that can be optimized. But for Brevis, you're looking at it from the perspective of the entire application, which is really great. And just as a last question before we close today's session, curious to hear if there's any kinds of announcements that you'd like to make on behalf of Brevis, or how any kinds of users or developers who want to get involved, say anyone who wants to integrate their own application with Brevis, what they should do next.
Yeah, for sure. So for developers out there, we're open. We're always online, and you can always find us through various different kind of channels that we have, like through Discord, through our Telegram, through our developer onboarding forum. So it's all available on our website. So if you're interested in building with Brevis, just let us know. And we have been supporting a lot of different teams building as well. And now in terms of announcement, we do have some exciting announcement coming up. But I think for the audiences, what we want to just briefly mention is that we have some user activation campaign called Proving Ground that is running right now. And this is not your kind of a normal testnet campaign that you can just like click the button, but that doesn't actually know what that button does. We don't want to run those kind of campaigns. What we really want to run is we are partnering with all our live mainnet launched partner project to let user experience and understand firsthand what are the benefits that can be brought by zk, what are some of the applications features that is enabled by zk. So that's something that is kind of different from our user activation campaign and community campaign comparing to others. We hope you can enjoy it, and if you're interested, definitely jump into our Proving Ground.
Yeah, sounds great. And be sure to learn more about the Proving Ground for any kinds of interested users and developers in the audience. And it sounds like Brevis is up to a really exciting time, and you guys have a lot of different integrations and partnerships as well in the moment. And you're also working towards the real-time proving initiative with ETHProof. So it's indeed a very busy but also very exciting time for the team. So thank you so much, Michael, for joining us on today's session, and really liked the conversation on the different types of areas that Brevis is focusing on, and also how flexible it is for any potential developers or any potential projects who want to integrate with Brevis have on the zkVM level itself. So with the zkVM being modular, but then also being able to integrate with the application side. So really enjoyed hearing about kind of all the design considerations behind Brevis, and hope to have another follow-up episode on this sometime again in the future.
Thank you so much, Alice, and it's always great to be on your show.
Yeah, thank you so much.